working. Good. So last time we have started our big int class, which we want to fill with more functions. So we will open that project and continue working on it. You might also remember that last time there was this homework assignment to create this from hex and to hex functions, which allow you to import and export numbers. So I was thinking that as a simple help to this homework, we could implement today a from and to bin function, which is quite a bit simpler. It only converts the number into a string of ones and zeros and vice versa, and can be used as a helpful template to accomplish the actual homework assignment. So let's start with that. So first of all, we'll just copy our existing names from bin and to bin. With the bin case, we really don't have much things that we can change. So we could of course add prefix and padding as well, but here let's be simple and make it just very basics. We can maybe add this later if we want to, but this is not so difficult, so I guess we will just skip it. From bin and to bin, zack, zack. Okay, here just for now return false, and this we can also copy in. Good. And first thing is first, we will want to set up a test case for the to and from bin operations. So we have here test text. I just copy it, test bin. We can copy the whole function, and then we just quickly edit it. Test bin. Yeah, we can go with a 64-bit number. Do we have calc installed? Only have the new one. Is this good enough? This copyable, so it should work. So let's switch to hex. We have this will be a bin string. So first of all, we need to generate some test case. We can use the same one. So it doesn't work. One moment, please. Let's install a good beta calculator. Yeah, this one, it gives us the good calculator from Windows 7. That is not so problematic. Where's the download? Programmierer, hex, zack. Wait, hex. Again, zack. Right, our number is too long. We need to break it into. So first we start with the low part. Then we add the high part. Zack, for the broken one. We don't need a bad case because actually we can just add a 2 to test this. Bin. And you can already start thinking whom of you would like to implement these two functions with some guidance. So if you don't know how to continue, you can just ask. You just need to be courageous enough to dare to try. Bin to bin fate. Actually, we can just search and replace every hex occurrence here with our. That probably will already be good enough. We can test it later on. And we of course first would want to start the toBin function, because this is probably simpler. So toBin, so we are here. So shall I pick someone, or is there a volunteer who would like to try implementing it? It's really simple. You just make a loop, and then you go through the whole thing. Actually, you make two loops. One loop that goes for each chunk, and one loop inside which goes for each bit in each chunk, and then you just append characters to the string. Okay, no volunteers. Then we need some Online-Würfel. How many participants we have? 5. 5. Number 2, Mr. Armin Kaufmann. Would you like to try to implement with some guidance the toBin function?
I mean, I can try, but I'm not exactly 100% sure of what I need to do.
Well, that's why I'm here. I will tell you what to do.
Okay. Yeah, I mean, I can try.
So connect through VNC as we showed in the last lecture.
Mhm.
That should work out of the box. I don't think anything changed. Although it might. Let me check quickly. This is 10.2 and my report redirection goes to don't pause. Yeah, that was wrong. Okay, now it should work. Wait, one more, maybe not. Oh, no, it should be fine. Does it work?
I just realized I didn't make an account for VNC yet. Hold on.
You don't need an account. There is a button you can, or a link you can press to continue without an account.
Oh, really?
Yes.
Oh. Okay.
Do we have the viewer here installed? Yeah, I can show it again. It's not installed in this file. VNC viewer, Windows. That's the whole VNC. We just want the viewer. Yeah, Bing is. Someone's already connected. Perfect.
Okay, yeah,
Then
I
we
think
don't
it
need to
worked.
show it. Wait, just. So, in principle, the toBin function is quite simple.
Oh, okay.
We just need to have two loops, one in the other. The outer loop, you can start by creating the outer loop. We'll just go from 0 to count of chunks -1. So that should be quite easy. the count of chunks, you can take a look in big int h how we have defined it. So it's on mptr and we have size in bytes, so you need to take mptr arrow usize divided by size of t chunk.
Usize, or what was that?
Yeah. Just, it's not a function, it's a normal variable.
Oh. Of T chunk. Oh.
You should, first of all, let me quickly use the mouse while it's complaining.
Wait.
Yes, wait, there was a small mistake. I have forgot to add the class to the name here. No, it's
Okay.
fine. And you should divide this by size of t chunk, since every chunk, since we have the size in bytes and we want to actually have the count of chunks. Okay.
But can I access T chunk like this? Isn't it private?
No, it's defined. Yeah, but you are inside the class, so you have access to everything that's private.
Oh yeah, okay.
I just will think there is a small caveat, namely that I should find. So ideally, we might want to use the code from line 19 until 21, because it gives you always the right value, not only if it's a multiple of chunks, but since we currently allocate always multiples of chunks, you need also the other two lines, 20 and 21. The idea is that if usize would be a fractional, then we would get one value too little. And you would here use just ucount, and you just need to add mptr to the usize in line 46.
This I can remove,
You
right?
can replace it with
ucount. So, okay.
And in line 46, you can add mptr before usize, since we don't have a local variable of this name. Good. And in line 47 as well.
Oh yeah, right. Okay.
Good. So this will process every chunk, and inside every chunk we need to process every bit. So we make another loop.
What am I counting? Or where is the upper bound?
Size of t chunk times 8. Because size of t chunk will give you the count of bytes, and we know every byte has 8 bit. So we need to multiply by 8. Okay.
I didn't know.
And now we need to so one thing we have not thought about is the order we are going through the loop. We just now went with the default order, starting at 0 and going until count. That might not be correct, but for now we can just start like this and see what comes out. So first thing we need is a facility to very easily add values to our string. We can do this simply by, so first you would need to, inside the loop, to check if ulen is greater 0. Yeah, and then inside you can asterisk pstr plus plus.
Wait, what was that? I'm sorry.
Asterisk. No, the symbol on the keyboard, multiplication sign. Yeah, that was the right.
Oh.
PSTR.
Oh, that's the name of this sign. Okay, I'm sorry.
PSTR, like the argument name in our, without the underscore, like the argument name in line 44. Plus plus is equals. And this allows us to write to the string at the current position and advance the position by 1 to the next. Since we give the
Ah, okay.
pointer by value, this will not influence the pointer which we gave to the function. And now we can
Hmm.
just assign it a 1 or a 0 depending on whether it is a 1 or a 0 or a 0.
Hmm.
And the way of doing it is simply you access mptr arrow p data, or how we called it, yeah,
Hmm. Yeah.
at the index I, and then you need, so this gives you a whole chunk, and now you need to peel out 1 bit out of it.
So
And
do I just write J then?
unfortunately, no,
Wow.
you cannot address bits this way. In fact, you cannot address bits at all in principle. Or like strictly speaking, what you practically do is you bit shift your data so that the 1 bit you are interested in is sorry, my tongue got entangled again. So you bit shift the number you have in usually to the right by as many bits as corresponds to the offset of the bit you are interested in, so that this bit becomes the last bit, and then you just end the value with 1, and then you will get either true or false, which will tell you was the 1 bit you are interested in 1 or 0. So to do this, you would use the shift operator, which is greater than two greater than signs after each other. Then you make j. Then you put the whole thing in brackets.
What, this entire time after the equal sign?
Yeah. And then you make end 1. Okay. And this will now evaluate to true if the 1 bit at the index j is 1, or it will evaluate to 0 if it's not if it's 0. So now we only need, well, yeah, but we we are not quite done, because this will just give you true or false, but you want the ASCII character 0 or 1, which is different than just 0 or 1.
Well, then I have to take a look at the ASCII table then.
No, you don't. It's quite easy. You just use the trinary operator. So you put the whole thing again in brackets in the line where you were. Yeah. The brackets might not even be necessary, but it's not good to do it. And then you write question mark. And the way this works is you have a condition, then you have question mark, then you have return value in case of true. So here you just write the character 1, which you write using a single quotation marks.
Oh, yeah. Like this.
Well, just put 0 and 1 in single quotation marks, since we want the ASCII
okay.
the integer value. Okay. Len you have already decremented perfectly. So we could run it. It will do something. It might not do it in the right order, but it will already produce a binary representation. Just go to main. I would set a breakpoint. Where would be a good place? Yeah, at probably it will return false. So you can set a breakpoint at line 42. You can do this either by pressing F9 on the keyboard, or by clicking the place where the red dot appeared. So you can also put the breakpoint in line 45. So we have 2 breakpoints in the failure and success case. And now we can run it. And then we will see that one is not the right one, because it oh, we forgot something important. That one is not the right one because it runs without the debugger being attached.
Okay.
You want the debugger to be
this
attached.
one. Okay,
yes.
okay.
I should be able to press run, or did it already run? No, it did not. Yeah. So it says it failed. And it provided a lot of garbage. So first of all, we should fix the garbage. So we close this window. You can press the stop button. It's on the right, like a
there. Okay, yeah.
We
nice.
go back to begin. And what we have forgot is that we are writing we are creating a C string, which is by definition null terminated, but we have never written the terminating 0. So we need to do two things. First of all, the condition for len must be len not greater 0 but greater 1, because we always want to keep one place spare, not used. Then we go to the very end and add a new line between 59 and 60, and just write asterisk p string is equal 0. Yeah. And now we can run it again. Then it should not longer produce this garbage. It still said it failed, but that was to be expected. The window is somewhere on the bottom. We need to open it. Yeah,
Okay.
so expected. Okay, we expect too little, and we got something. So let me have the mouse for a second.
How do I do that?
You just stop moving yours. As long as
Okay.
you can move it, then my mouse has priority. So let's see this thing. String test. Oh, this is probably already not enough. How long is this one? This will not tell me. If I write it like this, then it will tell me the length. Yeah, 160 something. So let's just make this 250 and run it again. Okay, so we at least get the strings somewhat properly. They're just not the same. So let's add a \n before each of them, which means a line break, so that we can see them on top of each other. We need to make the window a bit bigger. Interesting. The length doesn't seem to be right either, which is strange. We forgot something. This looks like this should be right, so we should go through all the numbers, j++ and count as well. Well, we can debug why it is not quite right later. First we need to find out if this is in any way, shape or form correct. So we could simplify the test case, for example. So here we comment this out and oops, and that out, and let's say we want something really trivial. So let's make the high value just 0. No, sorry, the high value is here. That brings me to the idea: is my reference number actually correct? It might not be. And here let's add something like just 0, like just 0, 1. So we expect in principle something that should be a lot of zeros and then nothing else. So just copy those two. So first we have the low, and yeah, so we enable this again. We can put them on top of each other. We don't care for the second one for now, and we override just everything with zeros except the last one. And now we run it again and see what we got. Okay, so it still says it's not correct. Okay, and we see aside of also the length being incorrect, so we are missing for some reason numbers. We see that our one
The
is
order. The order is reversed, maybe.
Yeah, the order is it seems to be completely reversed. So we just need to correct this here with I and J. If you want, you can do that. It's not that difficult.
Do I just swap them then?
No, no. You need to instead of I, you should write count minus I minus 1. Wait, is that correct? No, that's not correct. No, that is correct. Count minus I minus 1 should give you the right index, just on the opposite, like it inverts everything. And with J, you would in principle do the same thing. Just put J in brackets because we don't want the things to get messed up. And to make just no, not count. Size of tchunk times 8 minus j minus 1 times 8. And since it understands the order of operations, it should do the multiplication first, so that should be fine. Let's run it again. Or not.
Oh,
There
where
is
is?
somewhere a bracket too much or too little. I guess you need a second closing bracket there.
Yeah.
Maybe, or maybe not. Let's see. No, not. No, yes, that. Yeah, here. That should be good. Then it should compile. Okay. Let's see what it. It's still not happy, but the 1 is where it should be. So we can make now another test case. We can add. Let's say we make a pattern of a couple ones. So then 1 and 1, so 1, 1, 2, 4, 5, 6, 7, 8. That should be it. We have set 1 in bit 1 and in bit 2. Let's see. It seems correct as well. So, for example, we could now repeat this for all the bits, so that we set always the first bit of every byte, and then we see whether where we are starting to miss something. So I see a problem. So we see two things. We can correctly address the first 3 bytes, but then it seems that it fails, which is odd. What is our chunk size? Our chunk size is short, so that 1, 2, 3, we have 1, we have 2, we have 3.
Short is 4 bytes, right?
It's strange. I would expect the issue to be somehow a multiple somewhere and not like this. So the simple approach would be now to add some output text here that will indicate what is happening. So for example, we can add here just printf. You can write the function name. Printf is complaining because it needs an include. std.io. So we have this, then chunk %d, comma, and of course new line. And the currently processed chunk would be this thing. We can write chunk and small t. Of course, we could just have copied the text here, but it's kind of, if we ever change something, it's nicer to change it in one place. Plus, technically, it's more computationally efficient if we do this operation once and cache the value instead of redoing it however often we need to. Okay, and now here, basically do the very same thing. T or index is equals this. Oops.
Sorry.
Zack. Don't move the mouse.
Oh, sorry. I think you have a typo at size T, U index.
Yeah. Okay, so we have our index, which is here, and then we chunk semicolon d. So we will get, in principle, an overview of everything the thing is doing. We can put a breakpoint here, and we just run it. So 7, 6, 5, 4, 3, 2, 1, 0. That seems correct. and here we always go 0 until 15. That also looks for short correct, which is weird. First of all, maybe we have maybe this is not really the reference number might not be correct. So for the length, but that it failed to write these zeros everywhere, this is more concerning. So we can put a breakpoint here and test two things. First of all, this thingy, where is it here? Memory address of this thing. Ah, right. It's Win64. I just didn't set them. So that should actually be fine. More. Yeah, so this actually works. So we just need to find out why the size seems wrong. But kind of this looks correct. So I guess we just when copying here have lost some characters, because this makes much more sense. So let's try to fix our value, but probably just when copying failed. So we start with the high order bytes. Again, hex to bin. I know why it here. When I copy, it doesn't add the leading zeros, which we have 3 in this case. 1, 2, 3, and now the low order bytes. Hex. This one is fine because it does not have a leading 0. Oops. Copy first. Bin. Then we test here with adding some invalid numbers. But here when we paste it here, we will see that the length will now be correct. So if we run the code now, it should be happy with the first test. Let's try it. Yeah, it passed the... Well, it still printed a lot of text, but it passed, so we did not fail. We can now turn off the debug lines, because we don't need them anymore. And this function would be complete. So obviously now what we want to do is the other one. So maybe another volunteer. Shall I randomly pick another volunteer for the other function? We still have 5 people, so let's go to our random cube. 5. Mr. Usman Ali. Would you like to try? Hello, hello. Mr. Ali, are you there? Okay, apparently not.
I mean, I can keep going if you want.
Okay, sure.
With your guidance.
So, in principle, what we want to do is just the reverse.
Reverse
but
order.
they are it's on the top, but there are a few caveats with that. First of all, the bin number might not be padded to the right length, so we need to figure out how long of a number we actually want. So the simplest way is let me quickly take a look at what we already have here, because we have this alloc function which takes a size in the byte. So in principle, we just need to check how many bytes, we need to accommodate the number based on the length that was provided. So
Okay, so
the
we need to
length,
allocate memory
this we will
accordingly.
be doing using the function which already have this alloc data.
Mm-hmm.
We just need to provide the right size to it. So you could create a local variable size underscore t u size and compute into it the size in bytes, not bits, of what we need.
So, the size is stored in pstr or
No. So we are getting a string which's length is ulen, and the length is representative of the count of bits inside of our.
so times 8 then?
Yes.
Okay.
And just you need to add a line which is similar to line 21, which handles the case if it's like not a multiple of 8, but let's say 8 and 7 or 8 and 1 or something. So we just want to add one more entire byte if we have at least one bit more than we need. Just that you use modulo 8 instead of modulo size of chunk. And then use size plus plus. Okay. And now you
Why?
because there is a bracket
Ah,
missing.
okay.
Right. And now you can use the alloc data function to allocate the data.
I hate this.
There is just one thing we should do first. We should first call free data, so that if something has already been allocated, that it will be freed.
Or
It doesn't take arguments, just free data
okay.
semicolon.
And we allocate data with the length now or
U size.
U size?
And I see a small no, sorry, free data takes argument. MPTR. And here MPTR is equals alloc data on line 44.
Okay, yeah.
Is there a question? Someone raised their hand in the chat.
Hi, I have a question, but my question isn't about the coding and the program. I have a general question.
Yes.
And actually, today is my first session, and I have another class. That's why I cannot actually attend the class at 10.
Okay.
So I have another course in the university, and I want to know how everyone should actually do this part of the class with you to solve the problem, or I want to know how this program actually work. This course actually, what should everyone do for the courses?
Well, you of course get the homework, and you should participate during the lecture with these guided exercises. But you don't need to be present on every lecture. So we will see how many exercises per person we can bring under. So if you can come for the last 30 minutes, for example, and then do regularly something, that should be perfectly fine.
Okay, thank you. And for example, I'm not able to do some programming right now or during the classes, but I can participate and make suggestion. For example, we need something like a loop here or something. Is it that enough, or should I have a proper computer or something to write a program during the class, I mean?
During the class, you just need a computer with the VNC client so that you can connect remotely to the VM that you are seeing on the screen right now.
Yes, so it is a little hard for me to actually have that because for the courses I have in the university, but I can participate and I can parallel make suggestion or I but maybe one or two session be able to have that computer to during the class to write and how should I say, to connect remotely to your computer and write for others too? Is it that enough, or should I have it every session?
It doesn't, it must not be every session. So if you can participate a couple of times and show initiative, that should be good enough.
Oh, okay, perfect. Thank you.
Okay, so
That was it. Thank you very much.
let's continue with our from bin function.
Yes, sir.
Right, so we have allocated our data. So now in principle, it's quite simple. We just need the same two loops.
Mm-hmm.
And then, I mean, you can just copy them from below.
Oh, it's exactly the same logic. Okay.
Well, the loops are the same. The logic inside
Yeah.
the loops
Yeah.
will
Yeah.
change.
Yeah.
Yeah,
Yeah.
missing
Okay.
one closing bracket.
Am I? This one.
Yeah. And now just the insides of loop 2 will need to change.
Mhm.
And the idea simply is you are checking the string at the index I plus j, and then you have to set this particular bit inside the chunk. So you can delete lines 53 until 57 because they will be
Mhm.
different. And now you could the rest stays.
The rest stays. Okay.
And you could after the
What am I naming this? Just like
well, in principle you already have chunk and index. For the string you could call it uPosition, upos.
okay.
And the string position will be just I plus j.
I plus j.
Well, the position is I plus j. If you want to get the string value, then it must be type char, and I would call it differently than upos. So in this case, either pos is equals I plus j, or just char current
Oh.
or something is equals what you already have. Yeah. And now you should test, is it 1, 0 or something else? And if it's something else, then of course you return false because that's not a valid input.
Mm-hmm. Can I do that with the question mark syntax or run?
It's since you have 3 cases, you can either use an if or you can use a switch.
Mm-hmm. Okay.
I
I'll
guess
run then.
is there any of those more elegant than the other? Not really. A switch might be nice since we haven't used a switch yet.
Okay. I haven't used the switch in ages,
It's
to be
quite easy.
honest. So,
You write
and then you have the cases right
yeah.
inside.
So the value is current,
Mm-hmm.
and in the switch you just write case
Case.
value double point. So case 0, case 0 in the
Okay.
quotation marks, of
Yeah,
course,
yeah.
and case 1. Of course, after each case you need to break before the next case starts, otherwise it will fall through to the next case. And in case of default, replace break with just return false.
Mm-hmm.
And on the bottom in
Ah.
line 65 you can replace it with return true, because
Mm-hmm. Then it works.
apparently it should be fine. Yeah.
Yeah.
So now
Okay, yeah, that is fast, true.
So what we are now missing is the ability to set the right values. So the approach here to address the chunk is simple. For chunk we just use mptr underscore ptr arrow p data, a chunk. But to set an individual bit, you use a strategy similar like when you were checking it, just slightly different. So you start with the value 1, you bit shift it to the left, to the position where it should be, so you bit shift it by index, and then this thing you OR equals with the current value of a chunk, which will then set this 1 bit. Or in case of 0, you actually don't need to do anything, because if I recall correctly, we are initializing it here with memset, so it's already full of zeros. Why is complaining about count? Right, we need also
We haven't specified it, I think.
this line, this 3 lines here to get count. So we can just add them and then fill in the case 1. No, not at the beginning. There it's not initialized. After you made the alloc data.
Yeah. And now we're shifting the index.
So in the case 1, you can write m_ptr arrow p data. Here you address it at uchunk.
Uchunk, do we have that?
Yes, it's in line 50.
Mm-hmm.
And then you use the OR is equals operator, so pipe symbol equals. You need to put pipe before the equals.
What's so pipe?
Which language keyboard do you have?
What is it? Querz, the German one.
Then Alt-GR and then the is a greater smaller sign. That gives you a vertical bar.
Okay, the vertical bar thingy.
Yes.
Okay.
And is equals.
Sorry.
And this, what it basically does, it takes the current value and it ORs another value to it. And writes the result back to the variable from where it took it. So it's like mp data chunk is equals mp data chunk OR. Just that we save and don't need to write the whole thing twice. And what we now want to OR with it will be just the number 1 shifted to the left. So you like the before just well the one you need. Then you need the shift operator. It will be the less than sign used twice. That's the wrong way. And we shift it by index, which we already have, yeah. And this will set 1 bit inside the thing to 1, and then we proceed with the next bit, and so on, and so on, and so on. Yeah. Good. We can run
and it, I guess. For the 0 case?
The whole value has been zeroed before when we scroll up. In line here, 25, we have memset 0, so it is full of zeros anyway, so there is no need to do anything if in case of 0. Okay, let's run. We can remove the breakpoints. And you can remove them during runtime and resume from them. Just run it completely.
Okay.
Let's see what. Well, it failed somewhere. So. So we just copy the line. Okay, so this thing said it returned false on bin input. That is odd. That should not do it. Let's put a breakpoint here. Let's run it again. So we check this thing. Looks like it contains only. First of all, we check whether it actually was correct. Yeah, it is failing there. We forgot something. Not really. Current char at pstring, that should be fine. Let's see why it would return false. 2. Where did we add 2 to it? Call stack.
Hmm.
Well, but we didn't add 2 to it. We broke something. We broke something before. No, sorry. Yeah, the breakpoint is not helpful me. First, we check the other thing which worked fine. We need to run it again. Here we are in this case, which correctly should fail. Now we are in the other case, which looks like it's correct. But it still fails with current. Oh, with current 0. Right. We should terminate. We forgot to terminate the processing. So, as you know, the string ends with 0, and we need to know how far we are allowed to go. We used length to compute the length, but actually no, but it. Oh, sure, the I plus j is not correct. Here we have a bug. I plus j must be different because I needs to be multiplied with count. I must be multiplied with count, otherwise we will address this wrongly. Yeah.
Why exactly is
Well,
this?
because when I increases by 1,
Mm-hmm.
in string wise we should advance it by the count, by the size of. Well, not by count. Wait. We should multiply it by t chunk. Now it's correct. We want to, because we want to like add. We want the value that starts from 0, goes until this less than 1, and then continues at this and so on. So we need to multiply it with the count, with the size of the inner loop.
I get it. Yeah, okay, now that makes sense.
And plus j. So okay, let's try again. For simplicity, we can comment out the previous case which worked correctly. So let's run it. Okay, we still go to return false. We're at I8 and j 0. We said, let's see, so hex 512. That looks too much. Length is 128. Yeah, count. SPTR size and data size. We don't need times 8 because this is already in bit. We just need to validate here that it will be a multiple of 8, and that's it. Wait, no, sorry. We said multiply, but we want to divide it. Because this is in bit and we want it in byte, so we need to divide it. And then it will be fine. Let's see. The breakpoint here. Rerun it. Zack. 5. So count is 8, which is correct. So we have 8 chunks, 16-bit each of them. That gives us 128-bit. Okay, so let's run it. And now it's successfully finishing the operation. There is a case which we have not handled, which would be what if we would run it to this case. So we would not have, sorry, to this case. So we would not have enough bits. Like if we would have some missing tailing ones at the beginning. So for this case, we can add here a case actual 0, so end of string, and then just return true or break. Break should be enough. but let's go with return true, because this means our string is done. There is no more entry. There are no more entries in our string, and this is a valid case. So let's undo this, remove the breakpoints, and run it again. Let's see. Okay. Yeah. So our hex failed. I also see that we are missing all the backslash n's, so we can maybe add them quickly. Oops. So that it doesn't mix things up too much. And here the same thing. Zack, 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 zack. Okay. I'll run it again. It will now look a bit better. So we see big int success. But 2hex fails because we have not implemented 2hex, and also we didn't initialize it with anything, so it's just full of nothing. Also,
Oh yeah, because that was
yes,
in the homework, right?
yes,
The
that,
2x,
that,
yeah.
that you will need to do yourself.
I have a question regarding
yes.
the homework, by the way. You said, because I think last time you mentioned we should use printf. Should we avoid using std cout and cerr?
No, you can use it as well. It doesn't matter.
Okay.
It just I prefer the simpler thing since it's called low level.
Yeah,
and
of
std
course.
is not, but it's perfectly fine to use that.
Okay.
String test, string bin. Just a bit past it. That somewhere we got a hex output. Big int path. This is from here. Here we are missing backslash n's as well. It would probably be reasonable to add some headers. Some headers and maybe a few backslash n's before each test, so that we know where we are. Test bin, test hex. Yeah, now that my typos everywhere. Good, but this works nicely, and I think it is a good template for you to see how to help yourself to a successful homework completion. Right, and we have half an hour left, so we should take a look on what else we could find as a nice, easy, not too complicated homework for you. So we used during this lecture, this exercise here, already a few bit operations. So we had our bit shift, and we used the pipe operator, so the OR. Here we used AND and again bit shift. So and bit shifting things is quite simple. You just need to move the values around, as well as just byte-wise operations. That's even simpler. So before we take a look into more complicated things like addition, division, multiplication, etc., I think we should just start with those bitwise operators. And there is a nice feature of C++, that is, it allows you to define your very own operators, so that you later can reuse a variable of a given type, like you would of a complex type, as if you would use just a native variable. So like you have int, and you can write, let's say you define int a and int b, then you can just write a plus b, and this will do it. The same thing is if you define c big int a and c big int b, you can define your own operator for plus and minus and all the other things, so that then you can use those variables the same way like a machine type. So let's start with the simplest bitwise operators that one might need. So it's a big int is the return type, then write operator, and then we just write which one. So for example end, and this thing takes another big int as argument. We pass it as a reference, as a const reference, and the whole thing is a const function, meaning it also doesn't modify ourselves. It will create a new big int, which will be the result of this operation. And then we just repeat that a couple of times for OR. Then we also have the XOR, which is exclusive OR, and there is one more which might be useful, which is just the inversion operator. So Mr. Kaufmann asked before about in the null case, don't we need to do anything here? And we didn't, because we knew that it is 0. But if we would start with a unknown initialization state of our p data, then we would need to clear 1 bit. And to clear 1 bit is a bit more convoluted. So what you do there is you use the AND operator, and then you end it with the inversion of where you want the bit to clear. So what happens is you have let's write some test case. So you have 1 0 1 1 0 1 1 1, and then let's say you want to clear this one. So you first create 0 0 1 0 0 0, then you inverse that. That gives you 1 1 0 1 1 1 1 1. And then if you end this and this, 1 is 1, so let's just do the end. So 1 is 1, 1 and 0 is 0, 0 and 1 is 0, 1 and 1 is 1, 0 and 1. And you effectively just cleared that 1 bit that you wanted to remove. But as said, since we know it's 0, we don't need to do that. But that's where you very often would use the inversion operator if you want to do bitewise operations. Also, we can close the bracket, and as you see, Visual Studio then auto formats and adds some white spaces and stuff like that, so that the code is a bit more readable. Okay, so we have these operators, and what else we would also need would be a shift operators, so which we used as well. They are slightly different. They take as an argument int how much to shift. Okay, good. So we copy them and add to some of them some content. Although since those operators we also would like to use in this OR scenario, so where in the scenario we have the operator and the equals sign. So this is quite useful as well. So in principle we could copy them, but this we will do another time. In principle, you can just define additional operators. Or maybe we should do it. Why not? Just that those modify ourselves, so they return a reference on ourselves after modification. The inversion is here not included because it just inverts. There is not equal inversion. Ist gleich. It still takes the other one to operate, and here as well. So if we want to easily use those, what is quite a convenient approach is just to define helper functions. So functions which will just return a new instance of ourselves, and then we can call those functions from here and just return what they return, or call it from here and return when they assign to ourselves. But for this we would first need to implement the assignment operator, which we haven't done yet. And since we only have little time, we will I will complete the second half of the sample just on the next lecture. So we need an assignment operator, and in principle would also want a constructor which takes another instance, so that we just copy from the constructor. And this is something we might actually implement now, because we will need that very likely. The assignment operator in this case will be something for tomorrow.
So what we're doing now is operator overloading, is that?
Yes, that's
Yeah,
what
okay.
we're doing. Zack. So alloc data order punct pyro, and of course if this doesn't exist, then this is just here. And actually, do we initialize this already? Yeah, it's already even initialized to 0, so we just return if the other thing is not set. Then we take from it the size, and here we just take the other ones as pdata, and size is in bytes, so that's what we want anyway. So this is our copy constructor, and here let's just create the right functions for these operations. So this will be end Zack, and or XOR or XOR, then inverse or invert, doesn't take an argument, and then shift left and shift right. Shift left and shift right. Shift left and shift right, and here we just that should return a copy. So if it should return a copy, it should also take. It already works on this. Okay, so this is fine. Just return end from other. Those need to be const, all of them. Otherwise we cannot call them. And the other was not capitalized, so yeah, this all XOR invert, and here this is to the left, shift, and the other one will be to the right. And in principle,
can I ask quickly something?
is there a question?
Yeah.
Yes?
Why did you add the return thing behind the operator? So like the return and return or. So why
This?
did you add that? Yeah.
Because I want the operator to just call a function which does the operation.
Okay, I see.
Because
The function.
in the next step here, what we would do is, if we would have our assignment operator already up and running, this would be asterisk, this is equals, and other, return asterisk this.
Okay.
And they are not const, obviously they are not const, and assignment also not const. That was too much copy and paste. And this way we only need to implement everything once, and the operators here just dispatch the right functions. Or
Okay, I
X
see.
or shift left, shift right, shift left, shift right, shift I mean, in principle, the equals operator is not that complicated. We could implement it. Although here I will also go with this approach. We just call assign. And assign we then of course need to implement. This we made differently. Assign just assigns, it doesn't return anything. Right, so void assign other, and it's not const. Oops, it's a typo. And it's complaining that all these functions do not exist. So we need to make them. Maybe not here, maybe there. Zack. Okay. This all needs to be done, and right, assign as well. So assign is quite easy. It is just we already had kind of a sort of assign. We just need to free data, and then do this. But here in between, we have to set this to null ptr. Right, and then we just assign. So in principle, we could even have implemented our constructor here just by calling assign other. Right, and this here is also very simple. We just take this loop. It's almost simple. There is a caveat to this, because we have two, and we don't actually know if they have the same length. So count one, count two will be the other, count two. Then we go here until the lesser of the two. Actually, let's go different. Let's go to the higher of the two. So we will you count one is less than count two. Then count two. We want the greater one. Else take one. So this way we will loop to the longer of the two values, and of course we need one where we will output the data. So it's a big int result is equals is nothing. We just need to allocate to the right size. Punkt alloc data. This we should make a helper for that hash. Actually, we can check if that actually exists. If we have included it, max. It's not included, so let's define hash. Define. Actually, let's do this hash if and def max, because max is often defined hash, but not always. A comma b. A B A the the preprocessor definition, and which often is present in many systems, but we have so little includes that we are missing it, but we'll need it here a few times, so let's just go with it. Right, so max, here we take max of size. So we have something where to output our data result. Now we need the input chunk, so the chunk 1, chunk 1, and chunk 2. And now we need to ensure that we don't do some invalid access. So if e is less than count 1, then count 1 is this, so ptr data von e, else just 0, and then we repeat the same thing for chunk 2, just that chunk 2 ptr other. So this way we will either get the value or get 0, because we assume it's being padded with zeros to fill it up. And now we just do the operation. So result dot ptr data at e. We know that e is valid because it's the bigger of the two, so it will be large enough. And then this was an n, so chunk 1 and chunk 2. And for the other functions, it's and we need to return it, of course. Return will use the construction operator and assignment operator under the hood. But for all the other function, we just copy this, zack, zack, and just change one single character. So end is end, or is pipe, and XOR is this strange accent character. And since we're running out of time, I think those functions are simple enough that they would be a good homework for the next lecture, for the overnext lecture. So homework 2 from the something something, although we need to return something, otherwise this will not compile anymore. We can just return an empty result. Homework 2 from the, what's the 09. Example 0 back. Let's say 1 0 back 1 1 1 0 0 1 1 1. Okay. Implement this one. It should example, if we have this, we so this left, yeah, that's the right direction. Let's shift it by 2 values, so it's 0 0, so 0 1 1 1 2 3 and 1 2. So it fills up when shifting left, always with zeros from this side to the ringed example, which here is pretty true as well, just that this changes. 1 1 1 1 1 1 0. Correct. And special case. This one, the right shift is a bit more complicated. Special case. Respect sign. If it starts with a 1, then obviously this is also 1, but the others are also 1. So bit is left. And this behavior defines us whether a number is signed or unsigned. So if you have and of course I forgot something. And add a test case in main for this. This is a general instruction for every homework. Right, so if we have int x is equal, let's call it a is equals 0b 1 0 0 0 1 0 0 0 or int b is the same, and now we int a is gleich a by, let's say, 2 and b by 2, then we will see that this behaves differently. They used a, I apparently used a already for something, let's call it x. Okay. I used x a few more times. But I use also, yeah, it is annoying. I can just put this in a scope, then it should not complain unless you enable enough warnings, right? So we see a is just hex bin wait, what? A I thought that is decimal. 3 4 3 4 hex display was turned off. It doesn't show the leading zeros, but you see it just shifted it by the 2 zeros. But if we do the same for b, wait, please, that should be unsigned int b by 2. Let's run it again. Wait, that sorry, that's the test case. Wait, a, and we shift it in the right, and it is signed. Then it should take one, and it that's the problem. It needs to be a char. There was a 0 before because the test case here is not long enough. It needs to be a char so that the highest order bit is set. Now it will work. So a is, let's go with hex display. So a is just 88. Hex 88 bin is our test value, and AA is E2, hex E2, which, as you see, fills up with zeros. Now with B, it's again 88, but BB is 22, because it didn't, as you see here, there are zeros, because it filled out. So in this case, because it's signed, it fills out with ones, and in this case, because it's unsigned, it fills out with zeros. And we want this behavior here for the shift right as well. Later we will add a flag to this, whether it's signed or unsigned. Actually, I could actually do that right now. Ball beside is equals false. So this flag actually I can add so that this behavior can be made conditional. Special case, respect sign when ptr set is true. Good. So this is the homework assignment. These functions are pretty simple. You just shift bits around with a helper variable. This is even more trivial. You just take this case, cut half of it away, and then just use the invert sign. Yeah. And I guess that's that. Are there any questions?
Yeah, for the homework, the prior homework, are we allowed to use the CC type library? Because there's like convenient
Yeah, you can
commands
use
like
it.
isExt. Okay.
Any other questions? Okay, if there are no more questions, then we will see each other for the lecture in 3.5 hours. If you are participating, else we will see each other next week. In which case, have already a nice weekend. Bye bye.
Bye, thank you.